factoring is one of our harder topics, okay? So let's go through this step by step, and I'll remind you of some of the things that we learned about factoring. So the first thing I notice here, remember that factoring is the opposite of multiplying, okay? So here, for example, I was multiplying. I was saying, okay, I'm multiplying. So what I'm about to do is do the opposite. Say, like, what could I unmultiply from each of these terms, right? Like in this case, I could unmultiply 3x from each of these terms, okay? So in this case, what could I unmultiply? What can I factor out of each of these terms? And what I notice is, well, okay, this is a 3, and 3 doesn't have very many factors, right? 3 can only be divided by 1 and 3. So this can only be divided by 1 and 3, and this is also a 3. This can only be divided by 1 and 3. And 36, 36 has a lot of factors. 1, 2, 3, 4, 6, 12, 9, lots of factors. Okay, but I'm not going to list them all. Why? Because what I'm looking for right now is the greatest common factor. The greatest common factor. The factor that's the largest factor that's common to all of them. So it doesn't matter that 36 has a lot of factors because 3 doesn't have a lot of factors, and I need a factor that's common to all of them. So it can only be 1 or 3. So let's start with the greatest one. Let's start with 3. 3 can be divided by 3? Yep. 3 can be divided by 3? Yep. Can 36 be divided by 3? Sure can. So my GCF is 3. Okay, so now I'm going to set up my parentheses like this. Now what I'm trying to do right now in these parentheses is say, if I multiplied what I just did in my previous few questions, right? If I multiplied 3 times what would get me this? 3 times what would get me this? 3 times what would get me this? Okay, so let's take a look. 3 times what would get me 3x squared? Well, 3 times what gets me 3? 1, and it turns out this can be an invisible 1. And then I want to multiply 3 times 1 and get 3. I got the number. Now how about the x squared? Well, there's no x's here, so if I want there to be 2 x's being multiplied, they both have to be right here. Okay, now here I notice it's 3 times something is negative 3. Well, 3 times what is negative 3? Well, a positive times a negative is negative. 3 times 1 is 3, and here there's an x. There's no x right here, so 3 times what will get me an x? I have to put an x right here, right? And notice both of these ones I made invisible. I could have written 1x squared minus 1x, or I could have written x squared minus x. Those are the same thing. Now here, I notice this is negative, so I know a positive times a negative is going to get me a negative. And 3 times what gets me 36? Okay, listen to my question. 3 times what gets me 36? Okay, if you're like, oh, I don't know, what can you do? You can put in your calculator 36 divided by 3, right? That's what gets you that answer, and it's 12. Okay, now I can keep factoring here. I can keep factoring because this right here, this part can be factored. Okay, and remember this is what we spent a ton of time on. When we have a trinomial, 3 terms that looks like this, when this is 1, when a is 1, right? Like here, a is 1, right? If there's no a there, it's 1. Remember what I need. 2 numbers that add to b to this number and multiply to c this number, right? So like, for example, if I had x squared plus 5x plus 4, I would need 2 numbers that add to 5 and multiply to 4. Okay, sorry, I got a little close to the edge here. Okay, so here, what do I need? I need 2 numbers, and these 2 numbers need to add to -1 and multiply to 12. Okay, so this is the only thing I'm thinking right now. 2 numbers that add to -1. Oh, excuse me, they multiply to -12, right? This is -12. Because I know, remember this? They're going to go right here. Okay, so the first thing I think to myself, if I want numbers to multiply to a negative, it's going to be a positive and a negative. Now, when I go to add the positive and a negative, what's going to happen? I'm going to actually end up subtracting them, right? So I'm trying to think right now of two numbers that multiply to 12 and add, and when I subtract them, I get 1. And the key is just start with the multiplying, like this 1 times 12, 2 times 6, 3 times 4. Is that it? Yeah, that's all the pairs. So which one of these subtracts to get 1? Not this. 12 minus 1 is 11. 6 minus 2 is 4. 4 minus 3 is 1. So I'm going to use 3 and 4. Now, which one am I going to make negative? Well, I want them to add to negative, right? So think like 3 minus 4. That's this. That's positive 3 and negative 4. And that leaves, these cancel, and that leaves negative 1. Okay, now if I had made 3 negative and the 4 positive, that would have been positive 4 and negative 3. And these would have canceled, and that would have left positive 1. So I want it to be negative 1, so I'm going to use this one, positive 3 and negative 4. So this is going to be x plus 3 and x minus 4. And this right here, this is called factored form. This is the answer. This is what we're going for, to break it all the way down. And if I were to so if I take this and I were to multiply it back together, right? If I were to like multiply this back together, I would get this. And then if I were to distribute the 3 back in, then I would get this, right? So what I've done is the opposite of multiplication.